The field of biomedical engineering is a branch of engineering that integrates engineering sciences with clinical practices, biology, and medicine. Researchers explore subjects involving medical imaging such as X-rays and ultrasound, pharmacoengineering, which involves delivery of medicine inside the body, rehabilitative engineering such as prosthetics, and regenerative medicine such as stem cells and organ transplant. One such researcher who has devoted his life to the field of biomedical engineering is University of North Carolina at Chapel Hill's very own Dr. Devin Hubbard. Professor Hubbard did not take a conventional route into BME research. He received his Bachelor of Science in Biochemistry here at UNC. Later he switched to BME as he received his Master's and PhD in Biomedical Engineering from the UNC NCSU Joint Department of Biomedical Engineering. Today we will delve deeper into Dr. Hubbard's career and development as a researcher.
Yeah, I think I've always been interested in science ever since I was a kid. So that certainly played into my decision. I briefly lived in Europe when I was in high school, and when I lived there I had a set of really amazing chemistry and physics instructors that I got the opportunity to do some really cool experiments that have been done historically that I don't think I would have been able to do if I'd been in a traditional kind of school setting. That kind of convinced me of it. I really loved the idea of searching for solutions to unknown problems. So for me there was like a thirst for science that was behind the whole time. And I think the most appealing problems to me are ones where we take fundamental principles of science like math, physics, chemistry, biology, and apply them to engineering. So that's it was my experiences in high school and even late middle school that kind of turned me into the thirsty scientist. Well, I came in wanting to study physics and I really enjoyed it. I did some undergraduate research my first year and I really enjoyed it, but it wasn't for me. I was taking biochemistry and organic chemistry and I just fell in love with it. So I decided my junior year to switch into chemistry and still minor in physics and math. And so I majored in biochemistry, and at the time there was a research program for undergraduates to get involved in biomedical engineering research here at UNC. And so I had applied to that program because I thought it kind of sounded neat, and I did research with who would become my graduate PI, Dr. Dennis, and he does tissue engineering work. And that's actually how I got plugged into biomedical engineering, was because I was doing research as an undergraduate in chemistry, but working in the biomedical engineering department. So my lab does two things. The first is dermal imaging. So we're interested in wound care globally. Part of wound care is the assessment of wounds, and we're interested in topical wounds like on the skin. So think burns or maybe acne or sort of inflammatory conditions that can cause the skin to change color or shape or texture. And so one of the things that we do is we write computer algorithms that take images. They're not necessarily color images, but 3D images, infrared, sort of hyperspectral images, and we convert them using computer algorithms into essentially measurements that can be useful for physicianing. So that's one part of our research. And then my tissue engineering background is still sort of around, so I actually do some bioreactor design as well. So we have another footprint in disease detection for glaucoma. That's a great question. So I think my favorite part about BME is that it is truly at the intersection of fundamental sciences and medicine. So for me, even growing up, I was always interested in how I could apply physics. The first class I took here at UNC as a first-year student was physics. And it was like every day I went to that class, I loved it. And all I could think was, okay, how can I use this? And I would go home and solve a problem. And so for me, there's always been this sort of natural application-driven aspect to things. And it wasn't until my junior year when I found biomedical engineering where it was this obvious marriage of chemistry, biology, physics, and math together with engineering to create new techniques in medicine. And that's why I am where I am. I just love it. I think the first and easiest thing to do is just to get involved in science, right? So the idea of learning how to create a hypothesis and test it is pretty easy. And the good thing is that we're pretty much doing this in middle school already. I think the other easy thing to do is at home, get involved in taking stuff apart and play around with stuff. When I was in middle school, one of the things that I found that was really valuable for me, I had a hard time focusing. So what I discovered about myself was that if I focused on something that I was really passionate about in science, I could spend countless hours learning about it. And so I think for me, it was finding the things that I was interested in and just reading about them and learning about them. I think the passion and the spark for science comes from the underlying passion for a particular project, I guess. At least in my case, that's certainly true. I find myself cycling through different things even now, right? Like to keep my mind going and how do I keep excited about science, I continuously find cool things that I'm really interested in working on or learning about. So like, how do car engines work, right? That's a great question. Let's learn about it. And that was something I was interested in too. How do computers work? How does 3D printing work, right? These are all different things that I'm always really excited about. And I think my recommendation to a middle schooler would be find that thing in science that makes you really curious and just learn about it.